Hello everyone and welcome to another video with Mr. Math. Today we're finding the indefinite integral and we need to check the result, of course, by finding the derivative at the end. Okay, so we have a quotient here. We have a rational function x plus 6 divided by the root of x dx. Let's remember that we don't have any rule for division or multiplication when we find integrals like we had with derivatives. So what we can do here is we could just separate into partial fractions. Okay, we'll have the root of x, the integral of x divided by the root of x dx plus the integral of 6 divided by the root of x. Couple things, let's remember that the root of x is equivalent to x to the 1/2. So we'll have x divided by x to the 1/2 dx plus 6 divided by x to the 1/2 dx. Okay, so let's remember another rule that says that a to the n divided by a to the m. If we have the same base, we can keep the base and we can subtract the exponents. Okay, in this case we don't see it, but there's a 1 in there, so we'll have the integral of x to the 1 minus 1/2 dx plus the integral. On this case we'll have the other property that says that a to the negative n is equals to 1 over a to the n, and this will be x to the negative 1/2 dx. Okay, the integral of 1 minus 1/2 will be just 1/2 dx, and we can take advantage and put the 6 out and have the integral of x to the negative 1/2 dx. Okay, let's shrink this for a second so we have more space. Okay, so what we have here, the integral of x to the 1/2 will be the same, x to the 1/2 plus 1 divided by 1/2 plus 1, and we have 6. The integral of x to the negative 1/2 will be x to the negative 1/2 plus 1 over negative 1/2 plus 1 plus a constant c. Let's standardize our 1/2 there. Okay, 1/2 plus 1 will be 3/2, and this is divided by 3/2 plus we have 6 x to the 1/2 divided by 1/2 plus our constant c. Okay, let's continue with this process. We'll have 2/3 x to the 3/2 plus 12 x to the 1/2 plus c. Okay, this is our answer, but we need to make sure we come back and we verify this part. Okay, how are we going to verify this? We just add the operator of the derivative, the prime. I'm going to use the prime as the operator for the derivative. So we'll have 2/3 that multiplies 3/2 to the x to the 3/2 minus 1 plus 12 times 1/2 times x to the 1/2 minus 1 plus the derivative of a constant, which is 0. So this 2, 3, and 3 will cancel out. 12 divided by 2 will be 6 later on. So this will be 3/2 minus 2/2, which is 1, will be 1/2. 12 divided by 2 is 6, and x to the 1/2 minus 1 is x to the negative 1/2, and the 0 doesn't count. So we'll have root of x plus 6 over the root of x. If we process this, if we combine this algebraically, we'll end up on the same answer that we have above. Okay, let's do that so we kind of don't have any doubt. I'm going to amplify this one times root of x times root of x, just the first term, and I will have something like x over the root of x plus 6 over the root of x. Okay, this is equals to x plus 6 over the root of x, and this looks exactly like our initial problem right here. Okay, thank you for watching, and I hope this video was helpful for you.